Hi, good morning. I'm YY. I'm from NTUE. So regarding the certificate, some of you have asked whether when you're going to get a certificate. It will be we are going to have a simple ceremony at the end of the session. But if you can't make it and some of you have to leave after lunch, and let me know, then can collect a certificate from Jane, the lady helping us to organize this. Okay. So before the ceremony, or so-called beyond the cert, you probably want to see a simple demo from some of you. Okay? Thanks.
Test. So, good morning, everyone. And today we are going to talk about some advanced topic. In fact, I already introduced the XHR XML HTTP request, which is a part of AJAX and WebSocket in the course of in day 2. And today I'm going to talk about it in more detail. But we only have something like 1 hour in the morning to talk about this, so I'm going to cover every detail of them because there are quite a lot of things. So I will focus on WebSocket this morning, and I will actually create a little chat room, a running chat room with your guys. And okay, let's get started. But because we only have little time, so the AJAX part, maybe I will skip it a little bit. So, for example, I'm supposed to talk about the histories of communication, but who cares about the history, man? Come on. The introducing XHR, I already talked about that in day 2. You want to hear that again? No? Well, not so exciting, right? Level 2? Yeah, level 2, maybe a little bit cold, right? And then, come on. Okay, maybe you already see this example in day 2. This is how we send a XML HTTP request, which is asynchronous request to the server, and then we should get our response in this on-ready state change event. In fact, in XHR level 2, you can use another event called the onload. Onload is essentially equivalent to this 2 line. You don't have to check the ready state or the HTTP status code anymore. Onload means that the status is already full, which is ready to use the response, and the HTTP status is 200, which means the server is globally responding the data to you. Okay. Oops. Now in level 2, as I mentioned in day 2, there's some new features that you could use to add to your asynchronous request. You can handle timeout. You could submit something called form data, which is something like a key value data in the forms, and not just sending some text parameters. And you could also access the response as a binary data, so that you could, for example, read, for example, the server is responding a file to you, and then you can access the binary data. And you can monitor the progress. You can see how much data is already loaded to your browser and how big is the file in total. And there's something called the cross-origin request, which means that if your website lives in A.com, I want to send a request to B.com to get this data. Originally, the browser would forbidden this kind of cross-platform stuff, but in XHR level 2, you can support this cross-origin request but you need a little code in the server side. We'll take a look at it in detail later. So timeout is really simply handling something called a timeout event. So for example, we set a timer to 3 seconds, which is quite a long time already for a website. So if the response still not yet come back in 3 seconds, this timeout event will be triggered, and then you can do something. For example, I want to abandon the request, or I want to set a longer timeout value to keep waiting for the request. Or we can also submit a form to the server without an actual form on the web page. You can create a form, then put data in it, and set the data in it, and then send the whole form to the server. Alright. And we can also access the response data in the binary format. The only things here, in level 1 you can only have a response text and a response XML. They're all in text format, but now you can access the raw response in the binary format. So that's pretty handy if you're processing some file stuff. And you can listen to the progress event right here, this function. And you can get how big the file is in total, which is existing event, the total attribute, and get how many data you have loaded to your browser. This is loaded attribute. They're in bytes, and so that you can show a progress bar or something to indicate the user how big is the file and how much you already loaded. This is quite useful if you are creating something like a download manager, so that you can see the actual progress. Cross-origin would be the, I believe, is the most useful features of XHR Level 2, because there are so many APIs, so many data on the web, but they live in other domains. Actually, in the past, if we are trying to get some data from other domains, we need a proxy on the server side. So for example, we are in A.com, and then we want to fetch some data from Twitter, for example. And then we need to create a proxy on our server on the A.com. We send a request from the browser to our server, and then our server relay this request to Twitter to fetch the data, and then come back to my client again. So this is a little not that straightforward, right? And in level 2, you can actually do this cross-origin stuff. The client code doesn't change at all. You still create a new XML HTTP request. You send your request to the server. The key point is on the server. The server have to configure to response a header in the request to indicate that which domain he is willing to share his data with. So you can see that the JavaScript code, this part doesn't need to change anything. So when the browser tries to send a request, the browser will ask the server, for example, the Twitter.com, will ask Twitter, hey, are you willing to share some data with A.com? If the response from Twitter contains a header called the this one, called the access control allow origin. If Twitter.com said that, okay, I'm allowed that, for example, A.com to access my data, or I can say that, for example, we put a, sorry, how do you spell this in English? This sign. Star, right? Okay, yeah. Or you can replace it with a star sign, so to indicate that I'm willing to share my data or domain. Never mind, just take it. Then you can do the cross-domain request with this. So the control point is on the server side. The server decide which domain is willing to share his data. Server side, maybe we don't have enough time to do the XHR server side that, but it's quite simple. Simply returning some response. It's quite the same as you respond to a web page, but the only difference is that that's a chunk of data usually. Right? Now, actually today we are going to talk more details about WebSockets, and we are going to create a chat room, a real working chat room. You guys can create it all. And I already created a template last night. It contains a client-side index.html and a server. You can run it on your local machine, or you can, if you have some kind of server or domain, you can put it on top to run it. Okay? WebSocket, we already introduced that in day 2, right? It's a bidirectional full duplex means that you can send data in both sides in real time, right? I can send data from the client to the server, or the server, if he has anything to tell the browser, you can push data to the browser at any time you like. So, and WebSocket is over TCP and over HTTP again. So the protocol stuff is a little bit complicated. You can take a look at this chart. It's a little bit different from the chart in day 2 because I put more details in it. So, for example, I want to establish a WebSocket between the client and server. So the client will initiate a HTTP request first, so the underlying TCP connection is established, and then we establish the HTTP section. And on top of this HTTP section, we will send a handshake. You can actually see how this handshake looks like later. And we'll send a handshake package to the server. And the server will respond a handshake response to the client to finish this handshake process. And then we will consider that the WebSocket section is established, and then we can say data frames, control frames on top of this WebSocket connection. So these data frame and control frames are binary data package. It's quite like that. You send data on the TCP connection. And after you have finished the section, you can send a close frame as a control frame, send a close handshake on either side. The client can close it, the server can close it too. And after the closing handshake, the WebSocket section is ended, and the underlying TCP connection will be closed. So this is how a handshake looks like. It's actually a normal HTTP request. You can see that we are trying to, for example, the WebSocket is called a chat, and then we get this request. The difference is here in the upgrade and connection. We are telling the browser that we want to upgrade this HTTP section to a WebSocket section. Okay, and there is a several version of these kinds of protocol, but I'm talking the latest one. So the client will also send something called a WebSocket key to the server. The server will then take this key and then do some calculations in response to the client, so that to confirm that the server is looking at the project and doing the handshake correctly. So this is how the server will respond in normal if he is willing to upgrade to a WebSocket section. Also, there is an upgrade and connection header here. It's essentially the same here. The difference is that by taking this key, the server will calculate something called an accept, and then responds to the client to finish the handshake. So this is how you calculate the WebSocket accept with the key. You take the key from the client, and then you can calculate with this GUID is the constant string, and then you do a SHA-1 with this combined string, and then base 64 the result. So this will generate the assembly. And if you want to see how to do this in JavaScript, you can take a look at server example I will give you later. Okay. Oops. So this is how a data frame looks like. After the WebSocket section is established, you don't send HTTP requests on top of that section. You send something like this. It's a binary package. So the first 4 bits is a control to indicate that this frame is it finished. Yes, the first one, FIN, means that is it a finished frame, means that, for example, you have a very large package, you're going to need to divide it into several packages. So this, the first bit means that this is the end of a message, or not, so, or there are more to come. You need to combine multiple frames together to get a complete message. And there's an opcode here to indicate what this data frame is. There are several kinds, but generally there are two types. There's a data frame, which contains a data payload, or there's a control frame. For example, closing handshake is a close frame. It's a control frame, and there's something like a ping pong to keep the connection alive. And you can specify the payload length in here, or if you have a really big data frame, because the 7 bits length is not enough, then you can extend it to up to 32 bytes, 32 bits or 32 bytes, I guess. And then there's something called a masking. The masking is simply an algorithm to mask your data so that they don't send in plain text on the network. It's a simple mechanism to protect your data. And then follow would be the payload data. For example, you are sending a message, then the message content will go here. Right? So this is a possible opcode. For example, 0 means that this is a continuation frame. There's more coming later. You need to wait for them all. And 1 means that this is a text frame, or there could be also a binary frame. So if the opcode is 8, that means that this is a connection closed. So the server or the client, if we receive such a closing frame, should respond to close frame again to finish the closing handshake. For example, if I'm sending a hello world, not masking it, I'm sending it in plain text. So this would be something, this would be how the data frames look like. Because hello world is really relatively short, so the finish bit would be 1, and then the opcode would be 1 to indicate that this is a text frame, and then followed by length, and the hello world is 11 bytes again, and then followed by the payload. So it's all protocol stuff, so easy to understand. And this is how a close, sorry. Too much Gali in Singapore. Okay, now this is how a closed frame looks like. No payload. You specify the opcode as 8. And actually, this detail, if you are, you only need to know this detail if you are implementing on the server side, because on the client side, the JavaScript has already handled all these underlying things. There's 3 methods called connect, send, close. They exposed to JavaScript. You don't need to write these in JavaScript. You only need to know these if you are writing a server side. Okay. Now this is how a client looks like. If you are trying to connect to a WebSocket server from JavaScript, you simply tell the browser where is your server. Notice that the schema is not HTTP, it's WS, stands for WebSocket, and then if you are you want to establish your WebSocket section on top of HTTPS secure section, then this would be WSS, I guess. Yeah. And on open means that you already connected to the server, and then you could just use this send method to send data to the server, and then the browser, it would convert this message into a binary frame. We just store them and then send it to the server. And the server will analyze your package and then extract that data and then do something what it wants. On message means that you receive some real-time push message from the server, and then you can, for example, we show this message to the user, and then after we are done, we just call the close method to close this WebSocket connection. So again, you don't need to understand that binary data format if you are just writing the client side. Okay. Now, then let me create an actual walking chat room with you guys and ladies, of course, to see in action how to implement something cool with WebSocket. Okay. Oh, right. Any question about the introduction just now? No? Then we just dive into the code directly, okay? Can you see the URL clearly? You can download this project to your laptop. There's a little example. It's a template stuff that I set up last night. It contains a client and a server. So the server, there's a server. Oh yes, you still, besides downloading this project, you also need, let me download this first. Have you installed Node.js on your laptop? No? Yes, you also need to install a Node.js on your laptop to run the server. Node.js is a quite funny project. You can write the server side with JavaScript. Think about it. JavaScript on the server side, JavaScript on the client side. You don't need PHP, you don't need ASP, you don't need Java. I'm going to throw them away. It's pure JavaScript world now. Have you downloaded this already? Done? Okay. Then remember, install Node.js. Maybe it will take some time. It's quite a big package. Okay, now while you are downloading the Node.js and installing it, I'll show you how it works. Now this would be how it looks like on the when you downloaded the template project. It has a client and a server. The client is simply a index.html, and there's something called a web server.js. It's also written in Node.js, so that you can set up your local server very quickly. So this is how you're going to do it. Not this directly. So after you download it and install Node.js on your laptop, you simply type Node, and then you can run the Node.js. Or, because we already have something called the web server.js here, we could run Node web.js. See, then you would set that the HTTP server is already running in localhost port is 8000. Go ahead. 8,000. See? Then our local environment will be set up, and you add stuff to your index.html and text it on your browser. Jesus, the screen is so small. So this would be where we start to implement our chat room. Have you guys all downloaded Node.js? Done? Okay, now let's move on. Or before we started, we should look like to see how the chat room will work. Let me see if I have working copy. Oh yes, and I forgot to introduce the server side. There's another directory here, the directory called server. It has a WebSocket server here. I said it's a really simple WebSocket server. So what it do is that it will create a HTTP server. And again, you can see that this is JavaScript. It's really easy to understand. It will create a web server and then wait for an upgrade header. If a client is sending me a request with an upgrade header, then this function will be invoked. And then I'm doing the handshake. I'm going to get the WebSocket key from the client's request, and then calculate and accept, and then send it back as a response to finish the handshake. And then after that, I can listen on the data to get the binary data frame from the client, and extract the data from it. Okay? And then, for example, because we are creating a chat room here, so when we receive some text messages, we will broadcast to all other sockets which is currently connected to this server. So that when you say something, the other browser that connected to this server would also receive the message. And when the client is closed, we will remove that socket from our pool, and then we'll say that we'll say goodbye. Okay? If you are interested in how to implement data server side, you can take a look at this server.js. Again, this is written by Node.js, so we simply type node server. Then the server says, I'm up, come here, baby. Let me see this running. Yeah. Oh, connecting. One minute, please. Oh, right. Should be localhost. Oh God, you see the final code. No one copy it? Gosh. So we're opening two client here. You can see that there is a here we can say hello. Oops, typo. Hi. And then at the other end they will receive this message, and then we say hello back to it. And then this our so this simple chat room. And if you're not satisfied with sending text, that's boring, that's easy. How about sending some Gangnam style